One last thing to mention before we look at the molecular orbital diagrams for all of these diatomic molecules is another thing about labeling. There's a few different ways to label these orbitals. So we've already talked about sigma versus pi orbitals. And one of the ways, and I've used some of these notations already. One way is to call it, B, sigma A for bonding and anti-bonding. Another one is to use sigma versus sigma star, where star also indicates anti-bonding, right? These are anti-bonding, whereas the ones on top are bonding. And one final way that these orbitals for diatomic molecules, at least specifically, are labeled is using the labels G and U. So another one we can add here is sigma G orbitals are bonding and sigma U orbitals are anti-bonding. Now G and U are German words. G stands for gerade. I'm probably butchering the pronunciation. U stands for ungerade. I don't speak German, but I'll do my best. And these relate to the symmetries of the orbitals. And so if we draw a sigma bonding orbital, right, so it's kind of a big blob like this. If we imagine a point right in the middle between the two nuclei, in fact, I'll do this in a different color. This point right in the center of the molecule we call the inversion point. And if we take our orbital and take everything on the left-hand side, say a point along here, and pass through the inversion point and go to this side, right? So overall, this thing is positive inside of this lobe. The question is, if we do this inversion, we take the left-hand side through the inversion point to the right-hand side, does the sign stay the same or does it change? So gerade means even, or symmetric if we look at this inversion. And so a sigma bonding orbital is a gerade orbital. I'll come over here, give myself more space. And if we draw a sigma antibonding orbital, where we have this node in the middle now, right? We'll have our inversion point still. One side here is positive, one side's negative. If we go, say, take that same point and go from here to here, now we switch signs. We go from positive to negative. And this is ungerade, or we would say odd, or antisymmetric with respect to inversion. Okay, and so a sigma bonding orbital is sometimes labeled a sigma G orbital, and a sigma antibonding orbital is sometimes labeled as a sigma U orbital to indicate this. I want you to pause and think about pi orbitals, and is a pi bonding orbital gerade or ungerade, and same thing for a pi antibonding orbital. So hopefully you had a chance to maybe draw it out, think about it, but a pi orbital is opposite of the sigma, right? So a pi orbital looks something like this for a bonding orbital. And so if we, again, go about this inversion point, we go from positive to negative. So a pi bonding orbital is actually ungerade. And if we can do this for the same thing for a pi antibonding orbital. This is a very quick sketch, but you can kind of see that we'll always go from positive or negative to negative if we go through inversion point. So a pi antibonding orbital is actually gerade. And so this is another type of notation that's used to keep track of these orbitals. I prefer using just bonding, antibonding, but this notation is very common whenever you look at these things and is used in your textbook, so I want to make sure you know what it is. So in the next video, we will actually get to looking at the electron configurations of the dimers along the second row of the periodic table.